Hello students, welcome you to this session. In today's class, I'm going to teach one of a very simple topic, probability. It's actually one of a very simple topic. There are some formula, but more than that, your mental alert that is more important. Okay, formula are there, but it's not going to help you. So if you have to be very vigilant. So you have to understand the question correctly. So either your mark is full mark in probability or no mark. So such a topic this one, but it's very simple one. So listen very carefully. In this video, I'm going to teach all the basics. Then you can answer any question. So in the next video, I'll be teaching some sums will be very easy for you. So try to understand the concepts. Okay, that's very important one. Okay, so this topic is probability. First, I'll teach some theory part. There are some definitions. So probability, that is a chance. What's the chance of getting a head when tossing a coin? Or what's the probability of getting a rain today? So all these are some chances, right? So it varies. So some approximate value you can find here. So here, the first we have to see random experiment. So you know what is experiment, right? If you take a glass and you put it down, you know it will break. So it has a result, right? But sometimes you can't predict. You know either you are going to get this or that. But you can't say exactly what you are going to get, right? So such experiments are called random experiments. There are two conditions for that. The first condition is it can be repeated. Any number of times. That experiments can be repeated any number of times. And the second condition, that's the most important one, the outcomes. Outcomes means the results. The outcomes are not predictable. Such experiments, we call it as what? Random experiments. Okay. So you can say some examples also. If they ask some short note, you write the definition and you give some example. So you can give tossing a coin and observing which face turns up, right? Throwing a die. You know what is die? The 6 sides will be there, right? Some snake and ladder, some games play, but you won't play. On those days, we all played. Okay. So 6 sides will be there. In each side, some numbers 1, then 2, 3, 4, 5, 6. Okay. So throwing a die or taking a card from a pack of well shuffled cards. Okay. So all these are some of the examples for random experiments. So if they ask definition, you write not only writing the definition and give some examples also. Okay. So then next we have to study sample points. Sample points. What is sample point? You know, the outcomes of a random experiment are called sample points. Outcomes of a random experiment. Outcome means what? Results. Suppose when you toss a coin, what do you get? Head or tail, right? That's why we say it is a random experiment. You can't say exactly what you're going to get, but you know it is either or head. You won't get anything else, right? So in the case of tossing a coin, so example you can give like this. In the case of tossing a coin, sample points are H, T. In the case of throwing a die, the sample points are 1, 2, 3, 4, 5, 6, right? So this is one definition, sample points. The next definition you have to study is sample space. Sample space. This is very important. When you do the sums, this will help you. Okay, sample space, we denote it as S. First, I'll give the definition. What is sample space? Set of all sample points. Set of all sample points is a sample space. We studied what are sample points, right? All the outcomes. What are the results you are going to get? That are sample points. You write them in a set, that's all. So earlier I written H comma T. Now put a bracket, right? Set bracket. Okay. So set of sample points is called what? Sample space. So here I'll give a lot of examples. In the case of coins, if you toss one coin, what is the sample space, you know? The sample space is H comma T. You toss only one coin, you are going to get either head or tail. Suppose you toss two coins. What is the sample space? Both may be head, or first one is head, second one is tail, or first one is tail, second one is head, or both are tail. Any one of these four only you get, right? And the third one, suppose you toss three coins. What's the sample space here? You are tossing three coins, right? So I'll tell you a formula for that. Then you can understand very easily how many sample points will be there. So how many sample points are there in the case of what? Tossing a coin. There is a formula. The formula is 2 raised to n. The formula is what? 2 raised to n. When you toss one coin, 2 raised to 1. What is 2 raised to 1? 2. You are getting 2. When you toss two coins, the formula is 2 raised to 2. What is 2 square? 4, right? So 1, 2, 3, 4. Yes, you are getting 4 points. Then can you guess when you toss 3 coins, it is 2 raised to 3. What is 2 raised to 3? Some of you think it is 6, right? No, 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So you are going to get 2 raised to 3. That is 8 sample points you have to get. So listen how to write, okay? So 8 points we are going to write. So what I'll tell you some easy method. Starting with H, you try to write 4. Starting with H, totally you have to get 8. Starting with H, you try to write 4. Starting with H, so H, 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 T, H, T, H, H, T, T. Don't repeat the same thing, right? So you got 4. Now the next 4, very simple. Just replace H by T and T by H. Wherever H comes, you put T, and wherever T comes, you put H. So the next one is what? Instead of H, 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 you write what? T, T, T. Then you write T, T, H, right? T, T, H. T, H, T. T, H, H. Okay, so these are the sample points. You write it as a set. It is called what? Sample space. So for one more question or some competitive exam when you go, they may ask, suppose you are tossing a coin 5 times, then number of elements in the sample space. The formula 2 raised to 5, it is 32. So you don't need to write all the 32, right? So far in our syllabus, we have sums up to maximum what? 3 coins only. Okay. So this is one case. Coins. The next one is die. Dice. Suppose you throw one die. When you throw one die, can you say what is the sample space? When you throw one die, you will get what? 1, 2, 3, 4, 5, 6. You will get any one of this one, right? 1, 2, 3, 4, 5, 6. Suppose you throw 2 dice. Suppose you are throwing 2 dice. Dice is a plural form of die. Okay, so when you throw 2 dice, the sample space, can you guess how many will be there? In coin, I given a formula 2 raised to n. Same way in dice, there is a formula. It is 6 raised to n. So you can remember very easily because there are 6 sides, right? So 6 raised to n. So 2 dice means 6 raised to 2. 6 square, 36, right? So you will get 36 points. See how to write this. What are the 36? Both may show 1, 1, 1, 1, 2, 1, 3, 1 4, 1 5, 1 6. Or first may show 2, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Then what is the next one? 3, right? 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Then starting with 4, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Then with 5, right? So it is 5 1, some writing work, right? 5 2, 5 3, 5 4, 5 5, 5 6. Don't write 5 7, right? We have only up to 6. Then 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. That's all, right? No 7, right? So there are 36 points you get. So sample space, so write it as a set. For competitive exam or for objective question, they can ask, suppose there are 3 dice are thrown. 3 dice are thrown. 3 dice. Then how many sample points will be there? The formula 6 raised to 3. So 6 into 6 into 6, you will get 216. Okay, so like that. But we have sums based on 1 die and 2 dice only. Okay, so now we know what are random experiments we studied, right? It can be repeated any number of times. The outcomes are not predictable. There are some experiments are equally likely. Equally likely means the chances are equal. Suppose you toss a coin, either head or tail, the chances are equal only, no? Suppose you have an unbiased die. So there are 6 numbers, right? 6 faces. When you throw, any one of the 6 will come. The chances are equal. So the chances are equal. So we call it as equally likely. We call it as what? Equally likely. Okay, that means the chances are equal. Okay, just go through all these things. Once you understood this theory part fully, then the sums you can do very easily. Okay, now the next definition what I want to give is events. Events. Event, the definition is any subset of a sample space is an event. Look again. What is event? Any subset of a sample space. So you know what is sample space. That's what we studied so far, right? Sample space, you know, it is a set. For a set, you can write subset, no? So any subset you take, that is an event. Okay, any subset of a sample space is called an event. Okay, so now listen. Suppose I am considering the random experiment of tossing a coin. So we know when you toss a coin, the sample space is what? H comma T. When you toss a coin, right? You are taking an experiment of tossing a coin. The sample points are H and T, and the sample space is the set HT. Now I want the events, right? So in this case, what are the events here? So I said, what is an event? Any subset. So how can you write the subset? Already studied, right? So set itself, empty set, singleton set H, singleton set T. So here also the formula 2 raised to n. How many subsets, right? So 2 raised to n. There are 4 subsets. So there are 4 events. There are 4 events. So see here, is it possible? What is the experiment? You are tossing a coin. You are tossing only one coin. When you toss a coin, you are getting a head. Yes, it is possible. You are tossing a coin. You are getting a tail. Yes, it is possible. You are tossing a coin. You are getting head and tail. Is it possible? When you toss a coin, you are getting head and tail. No, it is not possible. Next one, when you toss a coin, you are not getting anything. Somebody else take it away. So that also not possible, right? So the first two, when you toss a coin, you will get either head or tail. Okay. But the definition says what is event? Any subset is an event. So all the four are events. But in which the last two, getting a head and getting a tail, both are possible events. That is possible. But the other two events, they are events only, but they are impossible events. Impossible events. When you toss a coin, you won't get both head and tail at a time, right? And you won't get empty set also. Okay, so that two events are called impossible events. So two types of events here: possible events and impossible events. Okay, and one more thing I want to tell you: mutually exclusive events. Mutually exclusive events. What is mutually exclusive? You know, event means it's a set, it's a subset, that's all. S is a bigger one, S is a sample point like our universal set, right? A is an event, that means you take few elements from that. So that is A is a subset of S, right? And B is another subset. I'm taking two events A and B. A and B are two events. So when can you say the two events are mutually exclusive means when you take the intersection A intersection B, when you find your answer is empty set. So nothing is common there. Then that two events are called what? Mutually exclusive events. So you can recall the results what you studied in set. In set also you studied a result like this, no? If nothing is common, right? So two sets, they are not overlapping separately, nothing is common. When you find intersection, you are getting empty set, then that sets are called disjoint sets, right? In sets, we call it as disjoint, and in statistics, that is in sets, in probability, we call that events as what? Mutually exclusive events. The meaning, nothing is common. A intersection B is what? Empty set, okay? And another one is there, that also will help you. Exhaustive events. Exhaustive events. Say two events are said to be exhaustive, the union you take A union B, you have to get the entire sample space like our universal set. So the biggest set, here it is sample space, right? Yes. So exhaustive event means two events are said to be exhaustive. When you take the union, you have to get what? Sample space, you have to get yes. Then if both the conditions are satisfied, we say they form a partition. Partition A and B form a partition means both A and B are. A and B are both mutually exclusive and exhaustive. Then that A and B are said to be what? They form a partition. Okay, so that is two conditions here. A intersection B is empty set, nothing is common for them. And one more condition, when you take the union, you have to get what? Yes. I'll give a small example for that also. Suppose you are tossing a die. Okay, when you throw a die, what's the sample space? 1, 2, 3, 4, 5, 6. A is the event getting an odd number. B is the event getting an even number. Then what is A? Can you tell me set of odd numbers? So 1, 3, 5, right? B is set of even numbers. What are the even numbers? 2, 4, 6, right? Take the first you check, are they mutually exclusive? Find the intersection A intersection B. What is common in both? Nothing is common, right? Empty set. So A and B are mutually exclusive. So this implies A and B are mutually exclusive. Then for the second condition, you find the intersection. Intersection got it. Now we find A union B. So what is A union B here? So union, you write everything, right? 1, 2, 3, 4, 5, 6. You will get the full set. 1, 2, 3, 4, 5, 6. That is, you are getting what? You are getting the entire sample space. So you can say A and B are what? Exhaustive. So now in this example, A and B are both mutually exclusive and exhaustive. So you can say they form a partition. Therefore, A and B form a partition. Suppose you want to show in a Venn diagram partition. Listen, normally what we do, you draw a rectangle, right? You draw a rectangle. Take two sets here, one is here, one is here. In this case, they are not mutually exclusive, right? Because something is common there, right? This is common. So you can't draw like this. If you draw like this, okay, now nothing is common. They are mutually exclusive. But are they exhaustive? Exhaustive means when you take the union, you have to get the entire sample space. But you won't get it, right? So in that, so you cannot draw two circles and all. See, I'm going to draw the line like this. Say this is A, this is B. So this is a partition, right? Now divided into two by that line. So A and B are two events now. What is the union? You will get yes. A union B. What is the intersection? Nothing is common for A and B. So this is called a partition. By seeing the diagram you can see, right? That line is a partition here. It satisfies both the conditions, right? When you take the union, you will get the full set. So exhaustive. When you take the intersection, nothing is common. So mutually exclusive. So this is how you represent what? Partition. And the last definition, very simple one, probability. The topic is probability, but we didn't study what is probability, right? Before that, what are the things we need to do sums that we studied now? Now just I'm going to give another just 2 minutes. What is the probability and what's the formula you have to use? Okay, then we go for the sums, okay? Probability of an event. Probability of an event. Suppose E is an event. E, any set. A, you can take B, some capital letter, because event means it is a subset of a sample space. Set always you use capital letter, right? Probability of an event is equal to N of E by N of S. N means what? Cardinal number, number of elements. So denominator is N of S. In the sample space, totally how many elements are there? That is what? N of S. Then N of E means the favorable cases. Okay, how many cases are favorable? So N of E by N of S. So please listen here. Suppose I'll give a small example. A bag contains 5 white, 3 red balls. My question is, so totally how many are there? 5 plus 3 is 8. So total N of S is 8. My question is, what's the probability of getting a white ball? What's the probability of getting a white ball? Denominator is total. 5 plus 3, it is what? 8. Then numerator favorable. That is, we need white. How many white balls are there? 5 white balls. So your answer is 5 by 8. Probability of getting a red ball. Denominator is 8 always for this question because total is 8, right? Favorable case, red. How many red balls are there? 3 red balls. So your answer is what? 3 by 8, right? What is the probability of getting an yellow ball? Total is 8, denominator 8. Yellow ball, how many yellow balls are there? Nothing. So you put 0. It is an impossible event, right? 0 by a number, your answer is what? 0, right? So the possible probabilities, if you add, only these are the 2 types of balls you have, white and red. If you add the probabilities, 5 by 8 plus 3 by 8. What is 5 by 8 plus 3 by 8? Your answer is 8 by 8. It is 1. So total probability is 1. Total probability is 1. Okay. The minimum value is 0. Probability cannot be negative. Okay. So probability of an impossible event is 0. And probability of a sure event is 1. Probability of a sure event is 1. Probability of an impossible event is what? 0. Okay. And all other probabilities always lies between 0 and 1. So 0 less than or equal to probability of an event less than or equal to 1. It can be 0. It can be 1. In all other cases, it lies between 0 and 1. Sometimes they give a question. Which of the following cannot be the probability? They give some negative number. You say it is not possible. Sometimes they may give a number more than 1. You say it is not possible. Okay. So probability always lies between what? 0 and 1. Okay. Then the next one I want to teach you, complementary events. Complementary events. What is complementary? No, just opposite. Suppose A is even solving a problem. What is the complementary? Not solving a problem. That is a complementary event. Okay, getting an odd number is an event. What is its complementary? Not getting an odd number. Getting a white ball. What is the complementary? It is not getting a red ball. Not getting a white ball. Getting a white ball is an event. What is the complementary? Not getting a white ball. Okay. So here one important result you need. So probability of an event plus probability of its complement. You can put E dash or you can put E bar. Okay, not E, that's the meaning. Okay, is always 1. You know the total probability is always 1, right? So an event plus its complementary always gives the answer as what? 1. Okay. Now when you do the sum, whenever R comes, A or B, you have to use union. If it is the case of probability, then you will get numbers. In that case, you add them. So R means you have to use union. If it is set or even, use union. For numbers, that is when you take probability, you have to put plus. And for and, if a word and is there, A and B, then you use intersection, A intersection B. In case of numbers, you have to use multiplication. Okay, some hints for you. For R, use union. For and, it is what? Intersection. Okay, so that also you have to remember. Then, one more thing you need. So when you do the sum, I said something in coin, dice, some bag containing some balls and all, right? Also you have another type of questions. So in complementary also you have some questions. Then we have sums in cards. So you must know how many cards are there, what are the different types of cards. You can't say, I don't like playing cards. Okay, you no need to play, but you must know certain things. Okay, so next I'll help you that one. But before that, another example for probability. Suppose a bag contains 20 pence. Totally there are 20 pence, in which 4 are defective. What is the probability of getting a good one? It is totally 20. So denominator you write what? 20. Defective 4. That means you know totally 24 are defective. That means how many are good? 16 are good, right? So probability of getting a good pen is what? 16 by 20. Or you can do in another way. Probability of getting a defective equal to 4 by 20, right? You can simplify, it is 1 by 5. Probability of getting a defective. The question is probability of getting a not defective. That is a good one. That means it is actually is complementary event, right? So it is 1 minus probability of getting a defective. Like that also you can write. So 1 minus 1 by 5. If we take 5 as LCM, 5 into 1, 5 minus 1, your answer is 4 by 5, right? Here also you are getting 4 by 5 only, no? So if you cancel, so this is 4 and this is what? 5, 4 by 5. So here also we are using the same result, probability of an event plus probability of its complement. The answer is what? 1. From here you can find anything. Suppose you want P of E. Take this P of E dash to the other side, you will get 1 minus P of E dash. Then P of E dash is equal to, if you want P of E dash, so what you can do, take P of E to that side, right? 1 minus P of E. But the basic result what you have to study is P of probability of an event plus probability of its complementary event. The answer is what? 1. Okay, now the last theory part about cards, right? Listen, in cards, total number of cards, 52 playing cards. There may be some joker, some guarantee card, remove all those things. So playing cards totally 52. So any sum, so for any question in cards, the denominator total number of cases, right? N of S, it must be 52, right? Total cards 52. So in card sums, denominator in most of the cases, it should be 52 only, okay? Sometimes they say we removed some cards from that. Okay, then in that case it change. If they give a pack of well shuffled cards, the total cards will be 52. Now let us see in this 52 how to categorize that. Depends on the color. There are two colors here. One is black, another one is red. One is black and another one is red. Both are equal in number. Total cards 52. So 2 colors. So each color, how many will be there? 52 divided by 2, 26. So there are 26 black cards and 26 red cards. Now I am asking a question. What is the probability of getting a black card? What's your answer? Denominator 52. Black cards, how many black cards there? 26. So your answer is 26 by 52. Cancel, you will get 1 by 2. What is the probability of getting a red card? 26 by 52, right? Okay, now there are 26 black cards. In that 26 black cards, we have 2 types. One is spade. Another one is clubs or claver, something. Okay. So that 26 we divide into 2. So each contain 13 cards. Spade, there are 13 spade cards, and clubs, there are 13 clubs cards. And red cards, the 26 red cards also we divide into 2. So one is hearts, another one is diamond. So each of same number, the 26 only dividing, so 13, 13. Now another type of question. What is the probability of getting a spade card? Total cards 52, spade cards 13, so your answer is 13 by 52, right? What's the probability of getting a red card? Red card I am asking. Red card means totally 26, so 26 by 52. What's the probability of getting a diamond card? How many diamond cards are there? 13, right? So 13 by 52. Okay, so just try to understand. Not solving how many questions you solved. Once you understood anything, you can solve even 1,000 questions. Okay. Now listen. There are 4 category now, right? 4 category. Among that 4 category, 2 types are black. Another 2 are what? Red. Now, in each category, how many cards are there? 13 cards. Let us see what are that 13 cards. Some of you are already know that, right? So now the 13 cards are, what are the 13 cards? There are some numbers starting from 2, 3, 4, 5, 6, 7, 8, 9, 10, no 11, 12 and all. Then some cards with some faces. Jack, some pictures will be there. Okay, Jack, Queen, King, and an ace card. There won't be any diagram on that. They put A. There is no faces you can see. Only Jack, Queen, King, you can see some faces. So that 3 cards has a special name, face cards. That cards are called what? Face cards. Jack, Queen, King. Okay. And the last one is not 10, it is what? Ace card. So you put A here. Okay, so these are the 13 cards. If you count, you can see there are 13. These 13 cards will be in spade, these 13 will be in clubs, these 13 will be in hearts, these 13 will be in diamond. Okay, so these are the 13 cards. What type of questions they can ask here, can you tell me how many kings will be there? How many kings? In that 13, there is 1 king, right? So in this spade, there is 13 spade cards. So here you can see 1 king, here 1 king, here 1 king, here 1 king. So you can see there are 4 kings. So probability getting a king, your answer is 4 by 52. Then you can cancel 1 by 13, right? 4 by 52. So totally there are 4 kings because in each category there is 1 king. So 4 kings are there. How many queens? 4 queens. How many jacks? 4 jacks. How many 5s are there? 4 5s, right? In each category there is a 5. How many face cards there? How many face cards? Totally I am asking. Totally. In that 13 there are 3 face cards, right? In that 13 there are 3 face cards. There are 4 categories, no? So in each category 3. So 3 plus 3 plus 3 plus 3. So it is 12, right? 3 into 4. There are 12 face cards. So what is the probability of getting a face card? 12 by 52. What is the probability of getting a red queen? What is the probability of getting a red queen, I am asking. Totally how many queens? In each category 1 queen, right? So totally there are 4 queens. But my question is red queen. Red queen means only these 2 cases you take, right? So in hearts there is 1 queen, in diamond there is 1 queen. So red queen, 2 red queens, right? So 2 by 52. If the question is getting a queen, 4 by 52. Because totally there are 4. If I specify red queen, only 2. Suppose if I ask, what is the probability of getting a diamond queen? What is the probability of getting a diamond queen? In diamond, there is only one queen, right? In diamond, there is only one queen. Then your answer is 1 by 52. Okay. What is the probability of getting a spade king? Totally number of kings, 4. Black king means these two you can take. In spade, there is one king. Clubs, there is a king. So both black only. So 2 by 52. But if I specify like this, a spade king. In spade, there is only one king, right? So then 1 by 52. Like that, they can frame any number of questions. Okay. So hope you understood all these things. So based on this, we are going to do a lot of questions in the next class.